Alright, welcome back guys for another beautiful day of digital learning. We're going to walk through one-step equations with integers. It's going to be a quick little video. So if you have questions, comment on your teacher's activity feed, okay? Let's go ahead and get started. Alright, I want you guys to go ahead and copy this example in your notebook. We have y plus 5 is equal to negative 11. Automatically, you guys are saying, oh, we know what 5 is. I know you know what 5 is, but can you tell me that? So, step 1, we need to isolate the variable using inverse operations. I think you guys remember that, but we're going to refresh your memory. Now, if you look at positive 5 in your equation, you have y plus 5 is equal to negative 5. In order to get y by itself, we need to use the inverse operation of positive 5, and that's negative 5. So I'm going to go ahead and subtract negative 5 on both sides of my equation. When I do that, I get negative 11 minus 5. Now, when I have negative 11 minus 5, I'm going to use the box method, just like we remember from Unit 8. Negative 11 plus negative 5, you're going to add what's in the boxes. When you do that, you keep the sign since it's the same sign, and you get y is equal to negative 16. So we've done step 1 and step 2. We solved, we got negative 16. Now, lastly, step 3, which is super important. You need to check your work. So if I plug in negative 16 into my equation, I get negative 16 plus 5 is equal to negative 11. Is this true? Why, yes, it is. If I add 5 to negative 16, I get negative 11. Negative 11 is equal to negative 11, which proves that negative 16 is the solution for y, okay? So let's go ahead and move on to number 2. Here is our next example. I want you to copy this in your notebook as well. So you're going to treat this as if you're still in class, so make sure you're taking notes, okay? So our equation, we have 4 minus x is equal to negative 14. So step 1, we want to isolate the variable by using inverse operations. Now, if you see here, we have 4 minus x is equal to negative 14. We want to get x by itself, so we need to get rid of 4, right? 4 is what's touching x. We want to get it away. So that's a positive 4, and we know the opposite of a negative is, the opposite of a positive is a negative. So I'm going to take away 4 on both sides of my equation. That means both sides of my equal sign. So when I do that, the 4's cancel out, and I'm left with negative 14 minus 4, which leads to step 2. When I solve, I'm going to go ahead and take negative 14 and negative 4. So when I use the box method, I'm going to add what's in my boxes, and I get negative x is equal to negative 18. Now, if you'll refer to the little sentence to the right, you'll see that your variable has to be a positive. It's weird when your variable is negative. That's not right, okay? So when we look at our equation, in order to make my variable positive, I need to divide by 1. Now that 1 is an implied 1, and there it is, and it's also negative, so we're going to take negative 1 away from x, okay? When I do that, I divide, because negative 1x is multiplication, and the opposite, or the inverse of multiplication, is division, hence my division bar. So when I divide by negative 1 on the left side of my equation, that cancels out. Negative 1 divided by negative 1 is positive 1, and that's done. That's canceled. So I'm going to do the same thing on the right. I divide by negative 1. I get x is equal to 18. Now, some of you are already noticing a pattern that it basically becomes positive 18 if you divide by a negative. Yes, you've noticed the pattern. But don't forget the last step, which is crucial, and that is to check your work. So if I took my solution of x equals 18 and plugged it in, I would get 4 minus 18 is equal to negative 14. Is this a true statement? When I evaluate, negative 14 is equal to negative 14. Yes, it is. Okay, so perfect. We're done with that one. Let's look at this one. You've got two more examples, and I want you guys to write these in your notebooks as well. I've got negative 5x is equal to 20. Now notice it's different from the other problems because now we are using the inverse operation of division. Okay, negative 5x, that is saying we're multiplying. If I substituted a number for x, say 2, that would be negative 5 times 2. So in order to undo that, I need to divide by the coefficient, which in this case is negative 5. When I divide negative 5 by negative 5, I get 1, and that cancels out. I'm going to do the same thing on the right. And now I get, if I evaluate 20 over negative 5, which is step 2, I get negative 4. Now last step, which is super crucial, I'm going to check my work. I'm going to do negative 4. I'm going to plug that back in for x because we are saying x is negative 4. So I've got negative 5 times negative 4 is equal to 20. Is this true? Yes, because two negatives, when I multiply them together, gives me a positive. So 20 is equal to 20. And that's done with that. Okay. So let's look at the next example and our last example. We have x over 4 is equal to negative 12. Now, remember what we talked about. There is an x there. However, there's also an implied 1. So let's break this down. We've got x over 4. This is a division problem, right? We have a fraction. So what's the opposite of a fraction? Or what's the opposite of division? Multiplication, right? We're going to multiply. However, since we have a fraction, what could I multiply 1/4 by in order to cancel that out? I'm going to multiply it by the reciprocal. So if you take a break and look with me here, if I multiply 4 times 1 and 1 times 4, I get 4 over 4. And that simplifies to 1. That's correct. I feel a little bit like Dora the Explorer. If I say map, you say map. If I say x, you say there's an implied 1. Very good. So this cancels out. And now I'm left with just x. Guys, I got rid of 1/4. However, what I did on the left side of my equation, I need to do on the right. That means I'm going to multiply by 4 over 1. And 12, negative 12, can also be written as a fraction if I put it over 1. Now, guys, 1 times 1 is just 1. I'm not going to explain that in depth. I would hope you know that. So x is equal to negative 48 because I multiplied my numerators. Now, last step, guys, super important, is to take negative 48 and plug it back into your equation. So I've got negative 48 over 4. This is my fraction. So 48 divided by 4 gives me 12. I have a negative divided by a positive. That's negative. So is this true? Yes, it is, because negative 12 is equal to negative 12. All right, guys, that's the end of digital learning day number 5. Give yourselves a pat on the back. You did great. Honestly, you guys, I'm super impressed with how diligent you are with doing your work. And I know that math is not your only class, so awesome job, guys. I'll see you next week, okay?